linear harmonic oscillator wavefunction. We know for a one-dimensional harmonic oscillator, linear harmonic oscillator, the potential V is equal to half k x square. And we know the Schrodinger equation, that is del square psi plus 2m by h cross square e minus v into psi equal to 0. So by substituting this potential here and solving for psi, we can find out the corresponding wave function. This is the usual way of solving for wave function if we know the potential, right? But here we are not going to use this Schrodinger equation to find out the wave function. Here we are using another method. In this method, we are using ladder operators. What are the ladder operators? One is creation operator, that is a dagger, and another one is annihilation operator. That is a. Right. So we are going to use these two operators and we are going to find the wave functions. Wave function for ground state energy, first excited state energy, and so on. You know how this creation operator operates. That is, if creation operator operates on certain state get n, then we will get an eigenvalue, that is root n plus 1 get n plus 1, right? So suppose this creation operator is operating on the highest energy state. That means you are right now at the top of the ladder. So again you are trying to go higher. So there is no way to go higher. So you will get this is equal to 0. Because there is no higher energy state, right? This is the top point of ladder. Next one, annihilation operator. If annihilation operator operates on certain state n, then we will get root n get n minus 1. Suppose this annihilation operator is operating on the ground state, that is the lowest energy state or lowest step in the ladder, right? Then there is no lowest energy. So if this annihilation operator operates on the state, then we will get this is equal to 0 because there is no further lower energy state, right? Here I am representing this ground state as psi 0. That is a psi 0 is equal to 0. And we know this annihilation operator, that is a is equal to 1 by root 2m h cross omega into m omega x cap plus I p x cap, right? So I can write this expression as 1 by root of 2m h cross omega m omega x cap plus I p x cap into psi 0 is equal to 0. That is equal to m omega x cap psi 0 is equal to minus I px cap psi 0, right? And we know px cap, that is momentum operator, is equal to minus I h cross dou by dou x. Now we can substitute that value also here. That is equal to m omega x cap psi 0 is equal to minus I into minus I h cross dou by dou x psi 0. That is equal to m omega x cap psi 0 minus into minus plus, and again there is I into I, therefore it is equal to minus h cross dou psi 0 by dou x. Now I am going to rewrite this expression in a variable separable form, that is dou psi 0 by psi 0 is equal to minus m omega x cap by h cross into dx. So our aim is to find out psi 0, right? So we have to integrate this function. So what do we get? We get log psi 0 is equal to minus m omega x square by 2 h cross plus log c. So we can find out the psi 0 value, that is equal to c e raised to minus m omega x square by 2 h cross. Now we got the wave function, ground state wave function. And now we have to evaluate this constant c. And also we have to normalize this wave function. Okay, so how we can do that? We have to do the normalization. That is integral minus infinity to infinity c square e raised to minus 2m, that is m omega x square by h cross into dx equal to 1. And here I told you a trick to solve this integral. What is that? That is integral from minus infinity to plus infinity e raised to minus a x square dx is equal to root pi by a. Here what is a? A is equal to m omega by h cross. Okay, so we have to substitute this a equal to m omega by h cross in this expression. So we will get the value, that is c square into root pi by m omega into h cross equal to 1. So we can find out the value of c, that is c is equal to m omega by pi h cross all raised to 1 by 4. So we can substitute this c value here. So we will get the ground state wave function, that is equal to m omega by pi h cross all raised to 1 by 4 e raised to minus m omega x square by 2 h cross. Here I am calling this term m omega by h cross as alpha square, that is equal to m omega by h cross. Okay, so I can rewrite this expression as psi 0 is equal to alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square. So here we got the wave function corresponds to ground state, right? Now we have to evaluate the wave function for first excited state. Now what we want to find out? We want to find out psi 1. So how we can find it? We know the creation operator, that is a dagger operates on certain state n, then you will get root n plus 1 as eigenvalue, get n plus 1. And we know the creation operator a dagger is equal to 1 by root 2m h cross omega into m omega x cap minus I p x cap. Now I am going to take this root m h cross omega inside this bracket, that is a dagger is equal to 1 by root 2 into m omega x cap operator is, we know x cap is x itself and p x cap is equal to minus I h cross dou by dou x. Okay, so we have to substitute this values also, that is x minus I into px is minus I h cross dou by dou x and divide by these terms, that is root m h cross omega, here also by root m h cross omega. So that is equal to, a dagger is equal to 1 by root 2 into, see this can be one of the root m and m will cancel and omega will cancel. So we will get root m omega by h cross x. Here minus 1 into minus 1, that is plus, then I into I, that is minus h cross dou by dou x by root m h cross omega. So that is root of h cross by m omega, right? And earlier we considered alpha square is equal to m omega by h cross, right? So alpha is equal to root of m omega by h cross. So we can rewrite these terms in the form of alpha. That is, a dagger is equal to 1 by root 2 into alpha x minus 1 by alpha dou by dou x. Earlier, we found the ground state wave function, that is psi 0. We can represent this in a Dirac notation, that is ket 0. Okay, so we know what is ket 0. So in order to find the next stage, that is ket 1, what you have to do? You have to operate this creation operator over ket 0, right? So we can find out the ket 1. That is the idea. Okay, that is, if this creation operator operates on state 0, this is the state we know already. So what we get? We get root 1 ket 1, right? That is next state. That is ket 1 is equal to 1 by root 1 into a dagger ket 0. Okay, so this is the expression for finding the next higher energy stage, that is psi 1. Okay, so in order to find out the next higher energy stage, that is psi 1, okay, that is represented as ket 1 is equal to 1 by root 1 a dagger. We know the a dagger, that is a dagger is equal to 1 by root 2 into alpha x minus 1 by alpha dou by dou x into ket 0. We know the ground state wave function, that is alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square, right? That is equal to 1 by root 2 alpha x alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square minus 1 by root 2 1 by alpha dou by dou x of alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square. So we have to take dou by dou x of this entire thing, right? That is equal to 1 by root 2 alpha x alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square minus 1 by root 2 alpha 1 by alpha derivative of this function. So we can take this constants outside, that is alpha by root pi all raised to 1 by 2 derivative of dou by dou x of this type, that is raised to minus half alpha square x square into dou by dou x of this type, that is minus alpha square x. Here we can cancel this one of the alpha and this alpha. Okay, so this can be rewritten as alpha by 2 root pi all raised to 1 by 2 e raised to minus half alpha square x square into alpha x minus, here there is one more minus, so plus alpha by 2 root pi all raised to 1 by 2 e raised to minus half alpha square x square into alpha x, that is alpha by 2 root pi all raised to 1 by 2 e raised to minus half alpha square x square into 2 alpha x. So this is the first excited state. Similarly, we can find out side 2. That is, we know if we operate a creation operator on the state 1, then we will get root n plus 1, that is 2 ket 2, right? So this is what we have to find out, that is ket 2 is equal to 1 by root 2 a dagger get 1. Okay, so to find out psi 2, what you have to do? You have to take 1 by root 2 a dagger psi 1. Okay, we know the value of psi 1. And earlier we find out the value of a dagger in terms of alpha. So just by substituting this expression, that is psi 1 is equal to alpha by 2 root pi all raised to 1 by 2 e raised to minus half alpha square x square here, and a dagger is equal to 1 by root 2 into alpha x minus 1 by alpha dou by dou x here. So substitute these values and do the mathematical manipulations. Then you can find out the psi 2. So this is the work for you. Please find out the value of psi 2. I tell you the final result, that is psi 2 you will obtain as alpha by 2 square 2 factorial root pi all raised to 1 by 2 e raised to minus half alpha square x square into 4 alpha square x square minus 2. This will be the final answer. Okay, so please solve and reach to this answer. So in general, we can write the different wave functions of linear harmonic oscillator, that is 1D linear harmonic oscillator, in following way. That is general expression is what I am going to tell you. General expression for wave function. That is psi n is equal to alpha by 2 raised to n factorial root pi all raised to 1 by 2 e raised to minus half alpha square x square hn of alpha x, where hn is, I already told you, it is Hermite polynomial. Where alpha is equal to root of m omega by h cross, and the various values of Hermite polynomial are h0 of alpha x, that is equal to 1, and the h1 of alpha x equal to 2 alpha x, and the h2 of alpha x equal to 4 alpha square x square minus 2, and the h3 of alpha x is equal to 8 alpha cube x cube minus 12 alpha x. For this Hermite polynomial, you can see if n is equal to odd, then the Hermite polynomial h is odd. Right, that is if n is 1, then there is x, right, only x, that is a odd function. And when n is even, h is even, that is h2, that is for alpha square x square. Okay, therefore this wave function is also, when n is odd, this wave function psi will be odd, and when n is even, then psi will be even function. Okay, now let us discuss a little more about the different wave functions. So first I am going to take ground state wave function, and we know the ground state wave function, that is psi 0 of x is equal to alpha by root pi all raised to 1 by 2 e raised to minus half alpha square x square, right, and this one is n equal to 0, that is a even function, therefore this wave function is also even function. If you're plotting this in a graph, then it will look like this one. This is a Gaussian wave function, right, that is e raised to minus half alpha square x square, so it will have a Gaussian profile, and this is x equal to 0 point, And now we want to find out the classical turning point. What is this classical turning point? If there is a pendulum, there is a bob and it is oscillating. Okay, so if this bob reaches this location, it will, so up to this position it will goes in this direction, but at this point it will come back. Okay, so that point is called turning point. The point from where it is changing its direction of motion. Okay, in a similar way, here we are discussing about a potential that look like this one. So in this potential, the particle is oscillating. So this will be the potential where the particle is turning. So this is quantum mechanical case. This is we are discussing in a harmonic oscillator. So similar to classical turning point, now we are going to find out this turning point of harmonic oscillator. So what is the condition here? The condition is energy of the particle, that is total energy of the particle, will be equal to potential energy. This is the condition for turning point, classical turning point. So similarly, here also we are considering the total energy of the particle become its total potential energy. Then here we know the energies of a linear harmonic oscillator, that is En is equal to n plus half h cross omega for one dimensional linear harmonic oscillator. So here we are discussing about psi 0. Okay, so the corresponding energy is E0. So we have to substitute this 0 value here. So we will get half h cross omega. So this is the energy. And we are dealing with a potential, that is linear harmonic oscillator potential, that is V is equal to half m omega square x square. So we can substitute those two values in this expression, that is half h cross omega is equal to half m omega square x square. Okay, so if you are evaluate for x, we can find out the turning point. That is, we can cancel this 1 by 2 and 1 by 2 and the 1 omega and this omega. So we will get x square is equal to h cross by m omega. That is x equal to plus or minus root h cross by m omega. Earlier we defined alpha square is equal to m omega by h cross. Okay, therefore this x is nothing but 1 by alpha. So the classical turning points are these two, x equal to minus 1 by alpha and x equal to plus 1 by alpha. If you are substituting this value x equal to plus or minus alpha in this expression, at this location you will get a finite wave function. Okay, that is you will get alpha by root pi e raised to minus half at this location. Okay, and at this location also you will get a finite wave function, that is alpha by root pi e raised to minus half. Sorry, I missed this 1 by 2 times. Okay, all raised to 1 by 2. And here you can see there is no nodes. Nodes is equal to 0. Only one antidot is there, but there is no nodes for this wave function. That is for ground state wave function. Now let us discuss first excited state. That is the first excited state wave function psi 1 of x is equal to alpha by 2 root pi all raised to 1 by 2 raised to minus half alpha square x square to alpha x. So here n equal to 1, that is odd value. So this wave function sin is odd. So how we can plot this wave function? Because this is odd wave function. So it will start from negative side. So it will look like this one. Okay. And this is x equal to 0 position. And you can see here there is a one node. In the ground state, there is no node, but here there is one node. And now we want to find out the classical turning points. That is, the condition is E is equal to V. Here this is wave function is psi1. So the corresponding energy is E1, that is equal to n plus half h cross omega, where we have to substitute n is equal to 1. That is, we will get E1 is equal to 3 by 2 h cross omega, and we know the V is equal to half m omega square x square. That is, we can substitute these values in this expression. That is, 3 by 2 h cross omega is equal to half m omega square x square. So we can cancel one of this omega, and 1 by 2. The remaining is x square is equal to 3h by m omega. So we can find out x, that is plus or minus root 3 h cross by m omega, and we know alpha square is equal to m omega by h cross. Therefore, x can be written as plus or minus root 3 by alpha. So these are the turning point. So this is one of the turning point, that is x equal to minus root 3 by alpha, and this is another turning point, that is x equal to plus root 3 by alpha. If you are substituting this value in this expression at this point, at this turning point, the wave function value is not equal to 0. It will have a finite value. Okay. Now the second excited state, that is side 2 of x, that is equal to alpha by 2 raised to n, that is 2, n factorial, that is 2 factorial, root pi all raised to 1 by 2 e raised to minus half alpha square h square into h2 of alpha x, that is 4 alpha square x square minus 2. Here n is equal to 2, that is even value. Okay, so the side 2 is also an even function. So if you are plotting this wave function, then this is an even function, so it starts from positive side. This will be the graph corresponds to this wave function side 2. And here you can see there are two nodes. And now let us find out the turning points. That is, condition is E is equal to V. And here this is side 2. Therefore, E2 will be equal to 5 by 2 h cross omega is equal to half m omega square x square. Here this one of the omega, and this will cancels, and this 2 also will cancels. So we'll get x square is equal to 5 h cross by m omega, that is x equal to plus or minus root 5 h cross by m omega, that is x equal to plus or minus root 5 by alpha. So one of the value will be here, that is x is equal to plus root 5 by alpha, and this is x equal to minus root 5 by alpha, and this is the position where x equal to 0. Okay, so in general, the classical turning points are, the condition is E is equal to V, right? That is, E is equal to n plus half h cross omega is equal to half m omega square x square. So we can cancel this omega and this omega square. That is equal to x square is equal to, so here 1 by 2 is there, so we have to multiply it. Therefore we get 2n plus 1 h cross by m omega. Therefore we get x is equal to plus or minus root of 2n plus 1 into h cross by m omega. That is x equal to plus or minus root of 2n plus 1 by alpha. So this is the expression for finding the classical turning point of any wave function of linear harmonic oscillator. See, the question is, consider a particle in a harmonic potential which is in the ground state of the system. Okay, so first we can write the ground state wave function, that is psi ground state. That is, we know for a harmonic potential it is alpha by root pi or raised to half e raised to minus half alpha square x square. And the next part of the question is, if alpha is changed to n alpha, that is, here you can see alpha, and if this alpha is changed to n alpha, then find the probability of finding the particle in the ground state of new potential. So if alpha become n alpha, the wave function become psi is equal to n alpha by root pi all raised to half e raised to minus half n square alpha square x square. Okay, the question is about finding the probability. Earlier in 1D box case, I told you there is a 1D box, okay, and there is a particle which is in the ground state of this box. That is, this box is of length 0 to L, and if I am extending the walls and now the length of the box is 0 to NL, then find the probability of find the particle in the ground state of new box. So such a problem we already discussed in the 1D box. So how we solve this problem? The initial wave function we considered as psi I, and the final wave function we considered as psi f, and the probability amplitude we obtained as integral psi I star psi f dx. Then we find out the probability is equal to modulus of probability amplitude square. Are you remembering? Here also we are going to use the same procedure. So initially this is our wave function and this is the final wave function, and we have to find out the ground state of new potential. Okay, so this is the ground state wave function of new potential. So these are the initial wave function and the final wave function. So by using these two expression, we can find out the probability amplitude. That is, probability amplitude is equal to minus infinity to infinity psi I ground state star psi f ground state into dx. That is, probability amplitude is equal to minus infinity to plus infinity alpha by root pi into n raised to half into e raised to minus half alpha square x square into e raised to minus half n square alpha square x square dx. That is, probability amplitude is equal to root n alpha by root pi integral minus infinity to infinity e raised to minus half into n square plus 1 alpha square x square dx. How we can solve this integral? We know a trick. That is, minus infinity to infinity e raised to minus ax square dx is equal to root pi by a. So here a is equal to 1 by 2 n square plus 1 alpha square. Therefore, we get P amplitude is equal to root n alpha by root pi into root of pi by a, that is 1 by 2 n square plus 1 alpha square. So we can cancel this alpha and alpha square and this root pi and pi. So we will obtain probability amplitude is equal to root of 2n by n square plus 1. So we got the probability amplitude. Now to find out the probability, what do you have to do? You have to take modulus square of probability amplitude. That is, we get probability is equal to 2n by n square plus 1. That is, when ground state is changing to ground state and when alpha is changing to n alpha. Okay. So what we are discussing is probability of finding the particle in the ground state of new potential. See, here the potential is a harmonic oscillator potential, that is half k x square. And we know alpha square, that is alpha square is equal to m omega by h gross. And here we know k is nothing but m omega square. Okay, so we can write this potential in terms of alpha, that is we can write m omega is equal to h cross alpha square. Therefore, m omega square is equal to h cross alpha square omega. That is, m omega square is nothing but k, right? That is, we can write potential V is equal to half h cross alpha square omega x square. So, in this expression, if alpha is changed to n alpha, that means the potential function will change. Then, what will be the probability of finding the particle in the ground state of new potential? This is the one of the question. And the second question is, if omega is changing to n omega, then what will be the probability of finding the particle in the ground state of new potential? And one more thing, that is, if k is changing to nk, then what will be the probability of finding the particle in the ground state of new potential? Here we find out this value, that is, we got probability is equal to 2n by 1 plus n square. Now we have to find out the probability for this one and probability for particle in the ground state of new box when k become nk. How we can find out? That is, now we are going to find out the second one. That is, omega become n omega. We know alpha is equal to root m omega by h cross, right? And now this alpha is changing, that is root of omega is changing to n omega, that is n m omega by h cross, that is equal to alpha prime is equal to root n alpha. So we can substitute this condition in the probability. That is, we now here in the first expression, when alpha changing to n alpha, the probability become 2n by 1 plus n square. Here alpha is changing as root n alpha. Therefore, probability will, that is probability p for omega become n omega, that is equal to, in a similar fashion, the probability become root n, that is 2 root n by 1 plus n. Now let us consider the third one, that is k changing to nk. So the potential function will change and we have to find out the probability of finding the particle in the new ground state. That is, we know k is equal to m omega square. Therefore, we can write omega is equal to root k by m. And here k is changing from k to nk, that is omega prime is equal to root nk by m. That is omega prime is equal to root n omega. So when k changes to nk, it is similar to omega changes to root n omega. So we have to substitute this root n function in this expression. Okay, so when it is changed to n omega, it becomes 2 root n by 1 plus n. So when p omega changes to root n omega, then the expression will be 2 root n all raised to 1 by 2 1 plus root n. Right, that is, this change is nothing but k changes to n k. That is, we got 2 root n all raised to 1 by 2 1 plus root n. So in order to find out the probability when a ground state is changing to another ground state, and here we know the potential function is equal to half kx square, or we can write v is equal to half h cross alpha square omega x square. Okay, so if alpha changes to n alpha, that is, potential is changing to n alpha, that is, here in this potential alpha is changing to n alpha, then the probability will be equal to 2n by n square plus 1. And if omega is changing to n omega, that is, this omega is changing to n omega, so the potential is changing, then the probability will be equal to 2 root n by n plus 1. And the third one, if k is changing to nk, see, this k is changing to nk, then probability will be 2 n raised to 1 by 4 root n plus 1. To remember this equation, you first remember this order, that is alpha omega k. Okay, so first consider alpha. Alpha is 2n by n square plus 1. Okay, when taking the omega, take root of all the n values, so become 2 root n. See, here there is n square, but here only n. Okay, then consider k. So again take the root, that is, here root n is there, so again we took root, so we got n raised to 1 by 4. Here n, so we took root, that is root n. Okay, so remember this order, alpha omega k. So the expression is 2n by n square plus 1 is, and the omega is equal to, take the root of n value, that is 2 root n by n plus 1. Then k is equal to, again take root of n values, that is n raised to 1 by 4 by root n plus 1. Okay, so please remember these expressions, these are very important.